Today's lesson is on how to subtract mixed numbers. This model shows 3 1/4. Copy down this model into your how-to books. So this model shows us starting with 3 whole pans of Rice Krispie Treats and another 1/4 of a pan of Rice Krispie Treats. So let's say that Mrs. Telestai was planning on bringing Rice Krispie Treats to her class, and Brian got into them, and Brian ate some before Mrs. Telestai could stop him. In fact, Brian ate so many that he ate 1 2/4 pans of Rice Krispies, much to Mrs. Telestai's horror. So what we need to do right now is we need to figure out how to model or show that Brian ate 1 2/4 of these Rice Krispies treats. So basically, the problem that we are modeling is 3 1/4 minus 1 2/4. All right, so if we want to show negative or subtracting, I like to use red for that because that's what banks usually use, and that's where the term in the red comes from if you have subtracted too much. So let's subtract the 1 whole Rice Krispies Treats pan and then 2 more fourths. So there's 1 whole pan gone, and then we need to subtract 2/4. So we might as well take this 1/4, and then we need 1 more fourth gone. Our answer will be whatever we have left. And it looks like what we have left is 1 whole and what would our fractional part be? 3/4. So our answer to this problem, as we can see with models, would be that Mrs. Telestai only had 1 3/4 pans of Rice Krispies to bring to her poor class the next day. And Brian had a big stomach ache. Go ahead and write this problem the traditional way, this problem that we just solved with models. I love using models because you can just cross out whatever you're taking away, which is great. With the traditional algorithm, it can get a little bit more complicated, and I want to show you how. So 3 1/4 minus 1 2/4. Let's say that we don't yet know that we're trying to get an answer of 1 3/4. We'll get there in a sec, but let's just pretend like we don't know yet. Let's start by combining our fractional amounts, just like we did when we added mixed numbers. Right away, we see that we've got a problem here. How can I take 2/4 away from 1/4? If I only have 1/4 to begin with, how on earth am I going to take 2/4 away? Well, we're going to regroup. Just like we do when we're going from hundreds to tens to ones, now we're going from whole numbers to fractional parts. We're still going to, and I hate to use this word borrow because we're not really borrowing it and putting it back, but we're going to regroup or borrow 1 whole from the 3 because it's got plenty to give and I need more over here. So I'm going to take 1 whole away from the 3. And the 3 is going to become a 2. Now if I took 1 whole away, that would be like changing this 1/4 into 1 1/4 because I've taken 1 whole away from it. But that still gets a little bit awkward because then I still have 1/4 minus 2/4. So what if we took that 1 whole and we translated it into the language of fourths? In other words, if I'm taking 1 whole away from the 3, how many fourths would that be? That would be 4 fourths that I'm taking over. So I'm adding 4 fourths. So when I recombine this 1 fourths plus 4 fourths, what I really have now is 5 fourths. And that's great because I can take 2 fourths away from 5 fourths. 5 minus 2 is 3. So 3 fourths. And hey, that matches the answer that we're not supposed to know that we can get. Now that we've dealt with our fractions by regrouping the 1 whole into the language of fourths, we can move on to our whole numbers here. And 2 minus 1 is 1. So that's where we get our 1 3/4 answer. Now you might be thinking, that is so much more complicated than drawing a model. And that's fine. If the problem has low enough numbers that you can draw a model, then that's great. But what if you were dealing with mixed numbers like 135 and 17/21 minus, okay, so you get the point. Are you really going to want to draw out that many Rice Krispie treat pans? Probably not. So in some cases, this method, this traditional algorithm method, is going to be what you want to use. But for a problem like this, 3 1/4 minus 1 2/4, you might as well just draw it out. So it's good to have a couple of different options for strategies for how to complete the problem. And we've just seen 2. Okay, let's try another problem. Copy this one down into your how-to books. 14 2/6 minus 9 5/6. Okay, so if we didn't want to have to draw out 14 Rice Krispie treats pans, what we could do is the traditional algorithm, the traditional method, where we start by looking at the fractional parts. I start with 2/6 and I need to take 5/6 away. I don't have enough in my 2/6 to take away 5/6, so I need to get some more value from the next door neighbor, which happens to be a 14. So if I want to take 1 away from the 14 becomes a 13. And we are giving 1 whole to the 2/6. That's 1 whole, not just 1 in the numerator to make it 3/6, but 1 whole. We need to translate that 1 whole into the language of sixths. So how many sixths would be 1 whole? Well, that would be 6 sixths. So we are adding 6 sixths plus 2 sixths. Okay, let's combine that together. Now we have 8 sixths. And now we can do 8 sixths minus 5 sixths would be how many sixth size pieces left? That would be 3 sixths. And now we can deal with our 13 minus 9, which is 4. 4 3/6. But wait, are we done? It's not in simplest terms yet. It's not in lowest terms. This fraction right here really needs to be simplified. So let's reduce that fraction. Let's divide both the numerator and the denominator by a factor that they share. In this case, divide by 3 and divide by 3. And you will get 1/2. So our final answer, dun, 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 is 4 1/2. 14 2/6 minus 9 5/6 is 14 1/2. Now this video has been pretty short because a lot of this is review. Really, the only new thing was the regrouping from the whole number and translating it into the language of the new denominator. So now I have a task for you that's a little bit more tricky. Notice that in our fractions, you don't have common denominators. So think about what you need to do first to make common denominators for your fractional parts. So think about the LCM, the least common multiple of 3 and 4, and then get your equivalent fractions. You might also need to regroup from the whole number 8 if you don't have enough to take away from. This is a tough task, but you know how to do everything, and if you've forgotten, you've got your how-to books. So first, make new denominators for the fractions, new pants so that they're wearing the same pants, same size pieces. Then you might need to regroup to subtract, and as always, simplify your final answer. You'll compare your answers with your discussion group tomorrow.